Hey guys, welcome to question MM343 of the Maths Methods Fortify study guide. So, in this question we've got a function f of x equals 1 on 10 x plus 1 squared with a domain of -1 to infinity. Now part A is a 2-mark question and says find the rule and domain for g of x, where g is the inverse function of f. Awesome. So let's just start with the rule for the inverse. And how do we find inverse? Well, we swap x and y and then solve for y. Okay? So swap x and y and then solve. Cool. So we're going to say let y equal 1 on 10 x plus 1 squared. And then we're going to swap. So therefore x equals 1 on 10 y plus 1 squared. So first step is to multiply both sides by 10. So we get 10x equals y plus 1 squared. Square root both sides, we get the square root of 10x equals y plus 1. And then y is equal to root 10x minus 1. Awesome. Which means that, therefore, g of x equals root 10x minus 1. So we need to make sure that we don't leave it in this format because the question's asking for g of x, not y. Okay? So that's our first mark there, finding that. And now we're looking for the domain. Okay? So the domain of the inverse is equal to the range of the original. Okay? So the range of this original, we have our domain, which is -1 to infinity of this, and at x equals -1, our y value is 0, right? So -1 plus 1 is 0, and then 0 squared times 1 on 10 is just 0. So our y value there is 0. It's a positive parabola, so it's going to go up from 0 like that. Which means that our range of our original is 0 to infinity, including 0, which means that the domain of our inverse is also 0 to infinity. That's our second mark. So guys, that's it for part A. Let's move on to part B. Part BI is a 2-mark question and says find correct to 2 decimal places the coordinates of points A and B, where A and B are the points of intersection between y equals f of x and y equals g of x. Awesome. So, well, how do we do this? Normally whenever we find points of intersection, we let both functions equal each other. So we say g of x equals f of x, or either way around, doesn't really matter. So we get root 10x minus 1 is equal to 1 on 10 x plus 1 squared. Now what I would do is just simply solve this in the CAS, because we do have that available, and we get x equals 0.13 and x equals 7.87. Now that's our first mark, and now we need to find the y values for these, right? Because we're looking for the points of intersection, the coordinates of those points. So because this is actually a little bit of a shortcut, so because these two graphs are inverses of each other, they're actually going to intersect at the y equals x line, right? So at these points, at the points of intersection, the x and y values are actually going to be the same, okay? Which means that our y values, respectively, are 0.13 and 7.87. So that means that A is 0.13, 0.13, and B is 7.87, 7.87. And that's our second mark. So that's it for part BI. Let's move on to part BII. Part BII is simply a 1-mark question, and tells us to find the average value of f of x over the interval AB, corrected 2 decimal places. So, what's our average value? Well, our average is equal to 1 over b minus a from a to b of f of x dx. Now, our lower bound is 0.13 and our upper bound is 7.87. So we get 7.87 minus 0.13 times from 0.13 to 7.87 of f of x, which is 1 on 10 x plus 1 squared dx. Now, because this is a 1-mark question, we can simply plug this into our calculator, and what we get is 3.00, which is corrected 2 decimal places, and that's our first and only mark and final answer for part BII. Guys, let's move on to part BIII. Part BIII is again a 1-mark question, relatively straightforward. And what we're asked to find is the area of the shaded region corrected to 2 decimal places. So again, 1-mark question, we can sub all of this into our CAS, but to set this up, we can say that the area of the shaded region is the area between these two graphs. So from our lower to our upper, so our lower is 0.13, upper is 7.87, and we're doing the top graph minus the bottom graph. So our top graph is our g of x. So g of x, actually I'm not going to write, well, j of x minus f of x dx, which gets us to 0.13, 7.87. G of x is root 10x minus 1, and then we're minusing f of x, so minus 1 on 10 x plus 1 squared dx. Now again, it's a 1 mark question, so we can just sub this straight into our CAS, and what we get is 15.49 units squared as our area. And this is our first and final mark for part B, I. Guys, don't forget your units squared on the end, because you'll be incorrect if you don't write that. That's it. So let's move on to part C. Part C is, again, a 1 mark question, so there's a fair few smaller questions on this MM343, which is good. Awesome. So part C says, let k, f of k be any point on the graph of f of x, and C says find f dash of k. Awesome. So in order to find f dash of k, we're first going to need to find f dash of x, which according to our CAS, I would just do this in our CAS, is x plus 1 over 5. So f dash of k is going to be k plus 1 over 5. That's our first and only mark for this question and our final answer. And that's it for part C, so pretty straightforward. Let's move on to part D. Part D is a 2 mark question, and says find the equation of the tangent to f of x at x equals k. Awesome. So according to our tangent formula, I really like to use the y minus y1 equals m x minus x1 as opposed to y equals mx plus c, because this really decreases the amount of work that you have to do to get to the end of the solution. So what we need here is a gradient and a point, all right? So we know that our gradient is f dash of k, right? So at x equals k, our gradient was k plus 1 over 5. We found that in the previous question. And our point is k f of k, right? Which is k, and then we sub in k for our x value. So 1 on 10, k plus 1 squared. And that's our point. This is our first mark, right? So getting the gradient and the point is our first mark. And then we can simply sub in our gradient and our point to this tangent formula. So y stays as it is. Y take away 1 on 10, k plus 1 squared, equals m, which is k plus 1 over 5, outside of x minus k, because that's our x value. Sweet. And then we can simply rearrange this to get y equals k plus 1 over 5, x minus k, plus 1 on 10, k plus 1 squared. That's our second mark. So guys, that's it for part D. We've found our tangent, we've got it in y equals mx plus c, well, almost y equals mx plus c form. Doesn't tell us to put it in any particular form, so this is completely fine. That's it for part D. That's our tangent. So let's move on to part E. Part EI is quite complex. It can be a little hard to understand what it's actually talking about, so we just need to kind of interpret it. So part EI is 3 marks, and it says let P of PP be the point of intersection between the tangent to f of x at x equals k and the line y equals x. Find the range of values of k for which P is greater than or equal to b. Alright, awesome. So let's deal with the fact that we've got a line y equals x first, right? So this line y equals x goes through the middle, like this. I'm just going to extend these out just to make it a bit more easy. And what I'm actually going to do is, actually no, I won't do that, all good. So, we've got a tangent to f of x at x equals k, which is just at any point. So let's say it's here. And we're looking for the point of intersection between this tangent, so let's say this tangent here, and this y equals x line. So this point here would be our PP in this case, right? If k was here, then our P point would be here. If k was a bit further down, it would be up here. If k was down here, the point of intersection would be here as well, because it would come down like this, as opposed to coming up like that. So the biggest thing to recognize here is that if this is actually quite difficult to explain. If this tangent here is the same gradient as our y equals x axis, there will be no point of intersection between the tangent and that y equals x axis, right? Because they'll be parallel, because they've got the same gradient. If this tangent is steeper than the y equals x axis, our point of intersection will happen up here, right? It will happen somewhere up here. If it's less steep than the y equals x axis, down here, it will come down like this and intersect down here, okay? So in order for P to be greater than or equal to B, that means that we want our tangent line here to intersect up here, right? Because B is this section here, so if P is greater than B, then that means that the intersection point is happening somewhere up here. The only way the intersection point can happen up here is if this tangent is steeper than the y equals x axis, right? Because if it was less steep, it would be down here and it would be intersecting down here. So that's our biggest thing. So our gradient of our y equals x line is 1, right? And we actually get our first mark here. So recognizing that we have to use that gradient is our first mark. We know that the gradient of our tangent, or f dash of k, is equal to k plus 1 over 5, right? We worked that out before, and we know that this is our k, f of k point here, right? Because we're looking at that tangent at x equals k. So we want this tangent, or this gradient, to be steeper than the y equals x, which means we want the gradient to be bigger than 1, right? If it's bigger than 1, it means it's steeper and it's going to intersect somewhere up here, which is greater than b. So therefore, so our gradient must be greater than 1, right? If it's equal to 1, it's never going to intersect, so we don't want that. Which means that our value of k plus 1 is greater than 5, so we multiply both sides by 5, which means that k is greater than 4. Now, that is this point here, actually, is our second mark, and this is our third mark. So a lot of the marks in this question actually come from the recognition of what you have to do, as opposed to the actual working itself. So if k is greater than 4, so let's say this was 4, if k is anywhere along here, that means that our intersection point is going to happen up here, which is greater than b, right? So it's going to happen up here. That's it for part EI, guys. I know this is a bit confusing. If you have any questions, just put them in the comments below, and I'll answer them as soon as possible. But apart from that, let's just move on to part EII, and you can ask any questions that you've got as we go along. Let's move on. So part EII really follows on from EI. It is only a 1-mark question, but if you didn't get EI, this would be pretty much impossible to get. So it says find the range of values of k for which p is less than or equal to a. So now we're talking about the fact that the point of intersection on the line is going to be less than a. So a is here, and the point of intersection is going to be somewhere down here. Now, just like in the previous question, if the tangent was steeper than the y equals x line, it would intersect up here. If it's less steep, it's going to be intersecting down here and intersect at this point here, which means that our gradient has to be, if k was greater than 4 before, if k equals 4, it's the same gradient. So if k is less than 4, it's going to be a less steep gradient, which means it'll intersect less than a, which means that k has to be less than 4, right? But we have a restricted domain on f of x, okay? So f of x stops at -1, 0. We're told that at the start. That's our domain here, which means that even though k is less than 4, it must stop at -1, which means it can be between -1 and 4, right? So k has to be greater than, k has to be greater than or equal to -1, but less than 4. So this is our final answer for part EII. That's our first and only mark for this question. I know this was a little bit tricky. If you have any questions, as always, guys, please hit me up in the comments below. But that wraps up MM343, and I will see you in the next video. Thanks for watching.